Hello folks, and welcome back to day 23 of Advent of Code. It's hard to believe that we're almost done, but there are really only 3 puzzles left. Actually, probably 2.5 puzzles, because the last part B is always a formality. So I'm pretty hype to be doing these last couple of puzzles with you all. And I, as always, thank Eric Wastel for making these puzzles. They're always super fantastic. I have a lot of fun every year. Although I admit yesterday was a little bit of a failure to read and comprehend, but, you know, it happens. So let's go ahead and get my code set up. And we'll get started. We should have the puzzle available to us in less than a minute. So I hope that everyone's day has been going well. I hope that you all have been having fun watching me do Advent of Code. I generally only do this during the month of December, so I'll be taking a break for a little bit, although you might see me doing some kind of, hey VWoo, thanks, good luck to you as well. So I usually wind up streaming like gaming or other kind of stuff during the rest of the year, and that's what I get up to. So yeah. Let's see what Eric has in store for us. It is technically a weeknight, but on the other hand, this is starting to get to the period of time in which people may have holiday time off, so as a result, the puzzles might get a little bit more difficult again. We'll see. It'll be exciting. It'll be real exciting. Where's my mouse cursor? There's my mouse cursor. Okay. Today's puzzle is called Crab Cups. Oh, so this is like playing the thing where you rearrange the cups and balls. Okay. Okay. Yeah. All right. All right, so this is essentially a ring buffer. Wonderful. I know how to do this one. I have done this in the past. So Golang actually does have a ring class, which is handy for this. So the input is literally the text 789 something something something. Okay, that's fine. All right. So the problem with the ring class is that the ring requires casting because it is not a type safe operation. But you know, it's fine. It works. It's okay. I think it's called containers ring. No, it's called container ring. Okay. So we're going to instantiate so we just know that this is this is just the line. This just takes one character. All right. So something like this. Now we have our cups, which is going to be a new ring. And we always will do that. Okay. So cups equals cups has an entry in it always, I believe. Yeah. value is going to be n, and then cups equals cups next, I believe. Okay, let's make sure that we got this right. So cups.value, and we need to, how do I do casting and going? So do the type assertion, which is, yep, like that, I think. Let's just make sure that my input is correct. So I think that looks correct. Oh, whoops, and I need to exit. Cups equals initial. All right. So that failed to print anything. Why did that fail to print anything? That's fascinating. This should work. What's going on here? Let's just read over the text of this. Picks up the 3 cups that are clockwise. So we pick up 891. We're looking for 2. We find 2. And then we put 891 down to the right of 2. Yep. Pick up 891. Destination is 7. I don't know where the destination came from. Oh, because it's going to 1 less than the current cup. Right. So we look for 7, and then we put down 891. But the current cup always only advances by 1, even if we're rearranging the rest of the ring. Okay, that's helpful to know. All right. Let us see. So I need to debug my ring implementation. Let me just check this. This is correct, right? Wait. Oh, reading the wrong input file. Ah! Okay, that explains a lot. All right. Yep, okay, so now we get the correct value, which is 789465123. Okay, yep, that's good. So now that I have confidence that I can traverse the list, let's go ahead and iterate 100 moves. Okay. Okay, so. And let's also do the simple, just so that we have that one as well to test against. Okay. So let's see. So the current cup always starts with the clockwise from 1, starting after the cup numbered 1, not including the cup numbered 1. Okay, that's important to know. Okay. So I think I have an idea of what the constraints are here. So All right, so we're storing the current pointer to our current cup. So we are always going to pick up the 3 cups that are clockwise. So that's just end link. So we end link the 3. All right, and now destination cup. Current value int -1. All right. If this would select one of the cups that was just picked up, we'll keep on going. Okay. So we need to know what was in what we removed. All right. Okay. Actually, this is a finite number. I'm just going to do this. It's annoying, but we're going to do it. It's not the most efficient thing in the world. If I only have to copy it 3 times, it is not worth putting into a loop. So next, there is also move. Okay, actually there is a formulation that works then. So all right, now so for each, we need to make sure if it was in removed, subtract from dest. Okay. Okay. I need to add this because Golang has obnoxious behavior around modulo of negative numbers. Okay. Okay, this forces the wraparound as intended. Okay. So now we should be knowing which one we're looking for. So the destination cup. Place the cups so that they are immediately clockwise of the destination cup. Okay. So now we just need to do the placement. And how does the link work? So that r.next becomes s and returns the original value for r.next. The elements of s inserted after r. Okay, yep, that's correct. That's exactly what we need here. So Okay, so now we loop through. All right. Actually, I can just always execute it this way. It'll be easier. Okay. So step equals current. Oh, but I need step to be accessible from outside the loop. Okay. Step equals step.next. If step.value int is equal to dest, then step link we need to link in the removed. Okay. All right, and now we handle the output, which is so we just walk through the cups. If cups value equals 1, then we break. So now cups should be on the cup labeled 1. I don't think I need this anymore, but I do need this. All right. All right. Okay, I think that should do it. Day 23, simple input, almost there. 40, that's going to be move. And then 45, step is not defined. Wait, I only need to execute this, in this example, 10 moves. So I'm going to execute 10 moves real fast. That should have finished by now. I have an infinite loop somewhere. So where is my infinite loop here? Let's test this. Okay, that's my problem. I'm executing the first 2 moves and I'm failing it to execute my 3rd move for some reason. Okay. So let's see, what do we have here? Immediately clockwise, keep the same orders when they were picked up. Select a destination cup. Oh. I bet the problem is here. Which cup am I looking for? That here's my problem. Let's try that. Nope, that's not my problem. Okay. So a problem here. Definitely need a function to just like literally print the ring. We'll handle that in a second. Okay. So what's happening here? So we start from the initial cup. Pick up 3. Our destination should be 2. Make sure that my destination value is correct. 0, 2. Wait, why is... Oh, because I wasn't sufficiently... Okay. Okay. So round 0, destination 2. Round 1, destination is 1. Wait. Why is destination 1? Label equal to the current cup's label minus 1. This destination should be 7 because both 8, 9, and 1 are present here. Oh, there is no cup 0. Ah! Okay. There is no cup 0. That's what threw me. That is incredibly frustrating. So, yeah. How do I handle this? I guess I can always add 1 to it. Guess I have to do it that way, don't I? Yeah, thanks for the prediction, the dough. It's exactly that. It's that there is no cup 0. This one has 9 cups. My actual example has 9 cups. Yeah. Okay. So, minus 2 plus 1 minus 2 plus 1. I think that'll do it. There we go. That's better. 926 58374. Good. Okay. Now I feel better about that. So now let's run into my real input. Oh, and I'm actually told what it would be after 100, so let's run it on 100. Okay, yep, that matches. Let's go ahead and feed this in. That is correct, rank 640. How, given that I made that silly mistake? Okay, cutting up from 6 until 1 million, and do all right. Let's do it. Okay, so I assume that this is relatively efficient because this is using Golang's ring type. Let's just get a feature flag in here. Okay. So if part B iters equals n million. Okay. Now I need to add this here. So let's make sure we have the right number of zeros. All right. So we're going to added is ring new. That's less than or equal to 1 million minus length of input plus 1. So if I go from, if I'm intending to populate 9 through 7, 9 minus 7 is 2, plus 1 is, yep, okay, that's correct. Okay. Added value equals I. And then, hey Eric, I'm having fun with this one. Added next. And then we, the end of this, we wind up taking last equals last dot link added. All right, I think that should work. So let's run it on if part B A is going to be move 1 to int, B is going to be move 2, and then will wind up, okay, yep. Okay. A, B, okay. Um, 35. here. All right. It's going to run for a little while. See exactly how quickly it's running. All right. Whoa, it do not like that. Oh. Wait, that's a problem. Why is... Oh. I feel very silly. There we go. So now that number is set way too low. Okay. So the immediate thing that comes to mind is that I am looking linearly for the position of a given number. But the thing about that is that that's going to be pretty slow because it's going to be potentially order a million every single time. So I probably do not actually want to be doing that. Let's just make sure that this runs at reasonable speed. Did I actually create a million? Okay. So let's just quickly, I do want to make sure that this is correct before I go any further. Because otherwise I know I might have a problem. Okay, yep, so I do, the first value is 3, indeed. And the last value that we see is indeed a million. Okay, I believe that. So now we can delete that. All right, so yeah, the slowest part of this is going to be this this search iteration. So I bet the best way to handle this is when I move pieces around, I remember what position everything's at. No, but if I have to mutate a million things and update a million things in the map, that's going to be painful. Okay. Yeah, because I don't want to have to move up to a million indices around. Wait. Oh. I see. Oh, I feel silly. Okay. I know exactly how to handle this. I don't need to update every entry. I don't need indices. All I need is to remember that this cache is a living thing. So, there we go. All right, now I can simplify this. So now, for instance, my belief is that over here, where I'm searching for the first entry, I can just do, for instance, that. Oops. Okay, now I feel much better about this. Okay. So let's run it with false real quick. That's going to be ring ring. Lines 38 first. Okay. There we go. So, yep, that still is the same. Great. So now we can fix this up too. So now I just take cache of dist dot link removed. Does that still work now? Yes, it sure does. Okay. Let's go ahead and check this in. And push this up. And now let's run this with part B as true. Yeah, that's much faster. Yeah. Okay. Got rid of the linear time issue, and now it runs in a total of reasonable amount of time. Yeah, the ring I love the ring inflation Go. It's one of the kind of least discussed things, but it is... Did I run it on the simple input? Yes. I didn't get the correct answer. Okay, so now I have another problem to bug, but at least this runs fast enough now. So we ran 10 million iterations. I'm only going to print every millionth iteration now. The 2 cups that will wind up immediately clockwise of cup 1. Yeah, because I believe the link class does not update the ring. It doesn't destroy existing elements of the ring. The rings are still valid pointers. Okay. So. Make sure this is still correct. Yeah, that's correct. Let's run it on my real input. And I do in fact get the same answer. Yeah, hash maps are amazingly useful, and I cannot believe that my spouse uses a language that doesn't have built-in hash maps. It's pretty fascinating. Okay. Starting from the number after the highest number on your list. Do I have 2? Oh, I see my problem. I see my problem. Oh, that feels bad. So if there are 9 things in my input, I need to, yeah, I needed to do that. There we go. Off by 1. Where is 62? Okay, so now I'm... Oh, yeah. That is correct. So I have a length of 5 and I need to get to 8. I need to add 6, 7, and 8. Yep. Okay. There we go. I am pretty confident this is going to work. If not, I will pay the wrong answer penalty, and then I'll spend a minute debugging, and then I'll have it correct. All right. That is not correct. Okay. Where did I go wrong? So I eliminated the problem where I had a duplicate, a duplicate label, because that was a little bit embarrassing. Okay, so I am getting completely different answers. Oops. That is what's in the simple. Yep, that is what's in the simple. Okay. So I have some other problem here now. Oh, am I adding in the incorrect order? No, I don't think so. Okay. Okay. Let's try running that really fast. Yep. So in this example, that is indeed starting from 10, going to 1,000,000. Yep, that's fine. 5, 4, 3, 2, 1. Counting up. Oh, I see my other problem. Maybe. So last is going to be the previous ring element to my current. Right. Just make sure that's correct. Yeah, so that starts at 3, which is the correct thing to do there. What does it now think the previous one is? Okay, that seems fine. Then what's my problem? Am I in fact running the 10 million moves? Yes. 2 cups will end up immediately clockwise of cup number 1. So that should still work. Yeah, I'm pretty sure I didn't break it. folks. Let's run this again, since it's relatively quick to do. Yeah, I'm getting a completely different answer. I think that's a little bit mystifying. Each number from 1 to 1 million is used exactly once. Let's just make sure. How many entries are in this? Yeah, no, that's fine. Yes, I get the same answer when I rerun it. It's... Yeah, I'm always getting this something 75 answer. Oh, yeah, this is running on my real day 23, which is why that number's different. Okay. Does my part B still work? Yep. So I'm pretty sure that this logic is fine. Because I think that would have already exercised. Doing 100 moves with my original input should have sufficiently checked this logic here. Yeah, I don't fully understand why I'm getting a different result. Well, let's try... I'm really curious what the numbers are after the number 1. Going for 10. Or going for 9 numbers afterwards. Thank you, Binary Vixen. I hope I get it soon too. I'm sure that there's just some minor problem here. Oh, whoops. Like, is the ordering correct and just... Let's look up what the ring class does, but I'm pretty sure it's fine. Linking them... R that next becomes S, yep. All right, so... Looking for 934001. I don't see it in here. Okay, I have something is deeper going on here. So find the element I'm supposed to append my removed elements from. Oh, wait. Current.nlink. What does nlink do? Nlink starts from r.next and removes the next n element. Yeah, that's fine. That's correct. Subtract 1. Yeah. Yeah. It's very little debugging guidance. Hey, is clockwise positive from the current direction? Yes. Yes, clockwise for me is always in the current direction. Yeah, and it's not possible to... Someone wants to share with me like some of the values from their first from their first like 100 iterations that might be able to help here. Cause yeah. I literally have no idea what I'm doing wrong here. Aside from it runs a bunch and then it fails. Whoops, I forgot to put the return there. Viwu, the thing I'm looking for to debug this is I'm interested in knowing, for example, what your sequence of current cup numbers is. That would be for the first 100 or so. That would potentially be helpful to me. I don't need my puzzle input. I'm just trying to even work with the example, which is 389125467. So this might reveal where I'm going off the rails in some fashion. And there I was having high hopes after I squished that initial bug. Oh, wait. I see my bug. I see it. I don't need the help anymore. Oh, that feels bad. Oh, that feels so bad. The problem is this. Right here, I was always picking... I was not wrapping around to 1,000,000. Oh. Okay. Oh. So yeah, I was using length of input as a shorthand when that's not actually true. This will take a while to run, but I'm caching the value, and then it's fine. So, oh. Okay. There we go. Oh man, yeah, okay. This was just a pure reading comprehension fail. That was literally all it was. Yep, okay, now it matches. Oh. Okay. Well, rereading the problem, it's a winning strategy. Yesterday was even worse for me. Yesterday I burned goodness knows how much time. Oh. But yeah, the thing that tipped me off was I started noticing that, yay, wait, rank 342? How? I spent so much time, I guess other people don't have access to the Go Ring class. Okay, well I got it. Yay, crab cups. Alright, let's get rid of my debug output, because I don't need it. Okay, and we'll just print out this. Okay. Let's check this in. Thank you very much for tuning in, and I will, oh no, I would have gotten rank 97. Oh, if only I had spotted that bug. That feels bad. Well, you know, that's kind of how the puzzle thing goes. Thanks for tuning in, folks, and I'll see you tomorrow for Christmas Eve. Cheers.